Hello, everyone, and welcome to our webinar. Today's session is about how to automate MSI build using GitHub Actions. Thank you for being with us today. My name is Cristina Constantinescu. I lead marketing initiatives here at Advanced Installer. Today's session will be presented by two of my colleagues. First one is Alex Marin. He is a professional with over 15 years of experience in the packaging industry, now holds the position of Global Service Operation Manager at Atos, the author of MSI Packaging ebook, and the prolific author on Advanced Installer blog. We have with us today also our colleague Ciprian Burcom, senior software developer at Advanced Installer and GitHub expert. You've probably read some of his articles on the Advanced Installer blog. As usual, a little bit of housekeeping before we dive in. First, about the Q&As. Please write down your questions at any time during this webinar, and for that, please use the Q&A pane of your Zoom control panel. Some of our colleagues joining us today are joining us today, and they will try to address your inquiries during the presentation. We will go through all of them with Alex and Ciprian at the end of the presentation anyway. Again, this is a live webinar and we are recording it. You've been noticed when you joined the webinar. So we will upload it on YouTube channel and send you the link with the recording within the next 24 hours. That being said, I would like to introduce our hosts, Alex Marin and Ciprian Burcom. Welcome, guys. Hi.
Hi, Cristina, and hello, everybody. Thank you for being here, and thank you for joining this webinar with us. So on today's agenda, we would like to talk a bit about the GitHub Actions, what they are, and show you some demos, me with Chip over here. So let's start with the basics. So the GitHub Actions platform simplifies the automation of your software workflows. It allows you to build, test, and deploy the code directly from GitHub, making it a super reliable, continuous improvement and continuous development platform. These features are not really new, and these have been available amongst the big players in the industry like GitLab or Azure Devops. So you might say it's not a pretty big deal, but actually it is, because if we all know, GitHub was designed for small indie developers who don't have the financial resources to invest in tools like the ones I just mentioned. What these actions allow you from GitHub is to run them on GitHub hosted runners, meaning you don't have to worry about investing in powerful machines or paying for Azure DevOps services to achieve these types of actions, right? So GitHub is already offering you a virtual machine where you can run this. And I can tell you from personal experience that we here at Advanced Installer have a complicated setup in Git. In order to perform these actions, we have tons of scripts which we have to maintain regularly in order for our projects and MSI builds to work correctly. And what's nice about the GitHub is that it offers a suite of standard actions out of the box, right? For different kinds of automations that you can think of and can benefit developers, such as C++ with Make, .NET Core apps with to an Azure web app, or .NET projects, and so forth and so on. We thought it also needed a way, right, to automate your MSI builds. So here is where Advanced Installer came into play and offered its own GitHub action. And let me share my screen and start with the demos. So bear with me for a little second while I share my screen. Okay. So now I could have just simply shown you a simple demo, right? I just upload a project up on GitHub and run it, and that's it. But I also thought of digital signing of your packages. Digital signing in our day and age is very important. So let's have a look on how you can not only build an MSI with GitHub Actions, but also how you can achieve the digital signature of it. Now, unlike Azure DevOps or Device Guard or just locally signing your package on your local machine, GitHub unfortunately does not offer you the possibility to upload your PFX file directly on the website in a secure location. So what you can do is take advantage of the GitHub secret support, right? This is a secure way to keep your secrets. Although this won't allow you to upload your PFX file, it does allow you to keep strings of information hidden from your organization or the general public. So in order to digitally sign a package or to achieve a digital signature, we must perform 3 steps. We must first encode our certificate into a base64 string, then save that resulted string inside the GitHub secret, and then add a job in the YML file. I will show the YML file a little bit later on how it looks and what it does actually. And that particular action will rebuild the certificate and use it when the build starts to sign your package. Now, encoding a certificate into base64 is actually quite easy. I have this code. This is directly from Microsoft. It's just a simple function to convert to base64 string. So I just wanted to convert my PFX certificate here. And if I hit the play button, there you go. The certificate is already converted. Now, what I need to do is just take this string from here. Bear with me. Copy it. And then just go back into our repository. And in our repository, we need to navigate to settings, secrets, and actions. As you can see, I already have a secret here, and this is the advanced installer license key. I've prepared a little bit of repository. I didn't want to send out license keys to everybody who is here. So yeah. So now we will create a new repository secret. So you need a secret name that we will use in the YML file. This is some sort of a variable, right? So let's call it base64 secret and paste our resulted base64 string, add the secret, and that's it. Now you have your certificate sort of in GitHub. The next thing we need is an actual advanced installer project, an AIP file. This project will contain the definition of your package in terms of files, folders, and whatever you have in it. So what I have here is a very simple minimalistic project. It only contains a few files. I think I also placed a shortcut, some registry, and that's pretty much it. As a note that I want to mention here. So as a note, all the files which you see that are stored here, these are stored as relative paths by default. So you don't have to worry about hard-coded paths when you upload your AIP project into GitHub. And as a best practice, it's good to save the AIP project near your folder structure, files and folder structure that you have. So for example, my AIP file is right next to the files that I have in it here, right? And also for these purposes of the demo, I went into the digital signature page and enabled signing. However, this is not necessary. I've only done it for this demo. You can have an AIP project without this enabled. And then with the support of the command line interface, you can place specific actions in the YML file to enable the signing directly from GitHub. So you don't need to change your project and then upload it back and so forth and so on. But again, I just enabled it here. Okay, cool. So now that we have our secret stored, our digital signature, we need to also upload our project up on GitHub. So bear with me here. Okay, upload that existing file. Let's choose the files and upload all of them. Okay, cool. I want to commit the changes. Let's see if it fails or it works. And it worked. Okay, the demo gods are with us. Okay. So now that we have the project uploaded, it's now time to create our GitHub action that will perform all the steps, the digital signing, the building, and so forth and so on. So let's navigate to the actions, and we will set up a workflow ourselves. Now, bear in mind, this is the part when you click that button, you can see that GitHub will create a separate folder structure in your repository with the .github/workflows. And this is the place where all your actions will be stored. But as you will see, actions are technically just these YML files. That's it. It's nothing very special. So if you delete a YML file from there, your action will disappear. I know, let's call this sample.yml. Doesn't really matter. And let me try to find the code for this. Bear with me for a second and paste it here. Okay. Okay. So I know it's a long code. I'll try to briefly go through it, not each and every line, but let's go through it together and understand what's happening here. So the name field represents, of course, the name of your workflow. You can configure it as you want. So keep in mind, we have build, AIP, and sign, right? And now in the YML file, you can define a set of jobs, and each job can have multiple steps or actions. Our YML file is configured to run on Windows latest, as you can see here. This is where you configure on which type of host you wish to run your actions. We are running it on a latest Windows version machine that GitHub offers. You can find a full list of them on GitHub. I think you also have Linux devices. You can specify a specific version of Windows. You can specify if you want a Windows servers and so forth and so on. So there are multiple options that you can choose here. Now, our first action is actually just to check out the repository code to make sure there are no issues there. And for those of you who work with GitHub, you recognize the checkout at v2, which is a standard GitHub action. Next, the second job that we have here is the one which creates the PFX certificate back from the base 64 string that we previously saved in our secrets, right? So this runs prior to the MSI build because we actually need the certificate before, right? And this runs in a PowerShell instance. This is where it runs, in a PowerShell instance. This creates a variable that stores our base 64 certificate from the GitHub secrets. You remember our secret, how we named it? It was base 64 secret, right? And then encodes the bytes from the base 64 string and writes the encoded bytes into a new PFX called cert.pfx. This cert.pfx is then kept in the runner stamp, in the actual runner stamp. Next, the third job is to actually build and sign your AIP project. I mean, to build your MSI. And this is where we reference the advanced installer GitHub action that is now available on our repository. This action will integrate the advanced installer tool into the GitHub. And as you can see, we have another secret here that you saw a little bit earlier, the advanced installer license key. So this is how you reference secrets, right? So secret dot something that you named there, right? The fourth job is to publish your setup artifact and upload it back to your repository. So you get the resulted artifact and you publish it so you can download it then, your MSI. And the fifth action and the last action is not technically really necessary. We just thought it's a good security measure that we have this year to delete the certificate after we complete everything. We don't want to leave certificates on runners, although runners may be reverted back for each operation that you do. I don't know, seemed a lot secure this way. Okay, so now that we have our YML created, it's time to start the commit and commit. And now if we go back on the actions page, interesting. Okay, this is new, never encountered that before, but appears we can run actions now. Now we have our build AIP and sign action that we previously did. So click on it and click on run workflow. And this should start. Unfortunately, with GitHub, it's being free. You don't have the possibility to tell it when to start the action and when to assign a machine and when to process it. So it might take some time. This is why on another repository that I had, I already ran this action just to make sure, because it could take from a few seconds up to 1 or 2 hours, depends on how GitHub wants to give you that machine. So once this is executed, it should look like this with the green circle and all, and very nice over here. Okay. And if you can also see what happened, right? You can go and check the log. So this is the setup job. It prepared the virtual environment. Then we created the PFX certificate, remember, and you can see whatever happened here. Then we build it, and then we build the MSI and signed it and so forth and so on. So this is some sort of a log file. And if you can see here, we have our setup artifact. So let's download it. Okay, and now let's extract it. Usually I use 7-zip, so that's why I need to do that. Okay, and now if we go through properties of this MSI, we have all digital signature here. And if you install it, you will have all your files, folders, and whatever you place there. So it's the actual MSI, which is resulted from the project that I showed you earlier. So that's pretty much it. I hope you enjoyed it, and I hope you understand how you can use this. Chip here has more examples, which he wants to show you. So Chip.
Hello, everybody. My name is Ciprian Burcă, and I'm a senior developer with the Advanced Installer team. In the second part of this webinar, I shall show you how to tackle 2 execution scenarios you might need. So first, I will show you how to configure our GitHub action to build a Visual Studio solution which contains an Advanced Installer setup project. I'm sure many of you are already familiar with our lineup of Visual Studio extensions, but for those of you who are not, you can download them from the Visual Studio Marketplace and give them a try. The extension enables you to create and build from scratch a setup project without leaving Visual Studio development environment, and it also integrates with MS Build, so you can run the same script on different machines and servers. Also, it is free, so that's a bonus. Yeah. So, for my second demo, I shall use Advanced Installer PowerShell interface to basically recreate the scenario that my colleague Alex showed you earlier, but without using the command line interface of Advanced Installer, just a PowerShell script. So let's get started, and I will share my screen with you. Yeah, I hope everybody can see my screen. So first, we shall create a Visual Studio solution. I will create a simple .NET application, give it a fancy name like my awesome app, and create. In the main method, I will add something like console.writeline hello world, the famous hello world everybody knows. Build it in order to make sure that everything is okay. Now it is time to add the setup project. The setup project type is called Advanced Installer Project. Next, give it IE setup project as a name. Right. So now we select the .aap file. We shall give it a product name like my awesome app and my awesome company. And now it is time to add the files to the project. We shall reference the other project by adding the primary output and also create a shortcut. You can add any other outputs you want depending on your needs. At build time, they will be automatically refreshed, and all the build files and all the newly created files will be automatically added to the setup project. So I will click OK and build the project again. Everything looks good. So now it's time to commit the changes to the GitHub repo, which I set up earlier. It's a fresh repository. Initial import, commit, and push. So now I will switch to the online repo. I shall refresh it. So you can see now my awesome app appeared in the repository, both the setup project and the .NET project. And I will now create the GitHub workflow as my colleague Alex showed you earlier from the Actions pane. I will take just a minute. I will copy the content of the YML file. So the structure of the first part of the YML file is basically the same as in the first demo. We have the checkout part. As you can see, the advanced GitHub action is more slim this time because we only need to deploy Advanced Installer on the GitHub runner. Advanced Installer itself will not perform the build of the AAP file this time because it will be taken care by MS build in the later step. All we have to do, all the necessary the advanced installer action just makes the necessary backup configurations on the GitHub runner, so MS build will be able to build our setup project. So I only referenced the advanced license key, which is mandatory only if you are using a paid project type like architect, enterprise, professional, and so on. If you are using a simple project type, there is no need to specify a license key. Also, you may notice that the advanced version parameter is missing. This is because it is not required, and in this scenario, the latest released version of Advanced Installer is downloaded from our servers and is deployed on the runner. This step adds MS-build to path to the path variable, so later build steps can find it, and this step runs MS-build and actually builds the Visual Studio solution containing the .NET app and the setup project. We shall commit this new file. Go to the, okay, so.
Yeah, you see, it's new. Enable actions on the repository.
Yeah.
It was not there yesterday.
It was not, yes, yesterday. Yep. There was a glitch, I think, in the morning with the GitHub. There were some problems I encountered. Maybe they didn't upgrade to their services. So we will run the workflow now. As my colleague said, this might take a while. So I will switch to another repo which already has a built workflow. And as you can see, in the log, MS-build builds both our .NET app and the Advanced Installer setup project. At the end, the setup is uploaded in the artifacts repository, and you can download it as you have seen previous. So this is the first demo. And now I shall we shall go to the second demo, which consists of the PowerShell support. Before moving forward, I shall grab the changes from the online repository to my local repository because I shall use the same repo. Yeah, to kick off the second demo, let's close Visual Studio for now because we don't need it anymore. To kick off the second demo, I shall create a new Advanced Installer project. It is an empty project. I shall name it demo and demo as a company. Also, I will enable digital signature. Like it's basically the same AIP project you've seen my colleague create earlier. So I'll have my certificate here. The certificate save. And push. That's it. We have created the project, and I will switch back to the online. Oh, sorry, code. To the online repo. Yeah, the AAP file is here, and create a new action. Okay, new workflow. So I will copy the content of the YML file. So as you can see, the part that handles the certificate, it is the same. To my knowledge, there is no other way to handle digital certificates in GitHub because, as my colleague mentioned earlier, They do not have support for secret files like other CI/CD services offer, like Azure Devops. So the first part is the same. The advanced installer action has a new parameter which is called advanced enable automation, which I think the name is pretty explanatory. It registers the advanced installer on the GitHub runner in order to be able to be used from PowerShell scripts. And now the most important part, the PowerShell script. I hope everybody can see my screen. I will zoom it a little bit. So the first part of the PowerShell script, I will break it down for you. The first part basically computes the path of the AAP project file after it was downloaded on the runner machine. It uses the GitHub workspace environment variable, which it is a predefined variable that the GitHub service populates. Basically, it is the location where the repository was downloaded on the runner. It creates a new advanced object. Advanced installer registers some COM interfaces on the runner. So this is how you can use it from PowerShell. It creates a new advanced installer object, COM object, and loads the project from the path we configured earlier. Now it loads using the digital signature interface. It loads the certificate from the disk where it was created in the GitHub temp runner. It also bumps the version of the package and sets the output folder of where the created package will be located. It is under a folder named setup in the workspace, GitHub workspace root folder, and builds the project. And that's it. The next step publishes the artifact. I shall give it a name Uno and commit the new file. We go again to actions. It is here, as you can see, and run it. Again, I will switch to a workflow that is already executed. And the advanced automation part can be seen here in the log. Basically, I have repeated the same scenario my colleague showed you earlier, but only using PowerShell. So this concludes the second part of the demo. As an important side note, you have seen that during the execution of the workflow, several changes were made to the AAP project. So these changes are not stored in the AAP file. They are not committed back to the repository. At the end of the workflow, the file, it is left on the same state it was when it was downloaded on the runner. So let's say, for example, bumping the product version, as you have seen in the PowerShell script. So this version will be just for the package that is currently built by that workflow. The AAP file will still remain to the original value, so no changes there. This is what I wanted to make to share with you. So right, this concludes this part of the webinar. Maybe we shall switch to some Q&As. What do you say, Alex?
Yeah, sounds about right. Okay, so let's take a question from Arun. Thank you for writing to us. So he asked a very interesting question: is application repackaging heading towards the DevOps concept? Not really, from my point of view, or not necessarily, Arun, because what we showed here with GitHub or all the other tools, you can do almost the same things with other tools, right? With other CI/CDs platforms. That's not really repackaging. That's more for developers. So if you are working maybe in a company where you needed to perform these steps manually, if you work in that type of environment, maybe yes, but repackaging does not mean that. So repackaging, it means that you need to get some sort of sources and then make them available for your clients, or maybe repackage them or change them. And this is not the scenario here. You always need just to keep a repository with all of your projects and so forth and so on, just to build them again, which is not feasible. The next one is from Scott. Chip, could you take that?
So how do we use an EV code signing certificate, token-based? So our colleague Catalin already answered this question. It presented an article we have on our website, but GitHub, if you are referring strictly to GitHub, you can only use a stored certificate like we used in the demos, or you can reference some services like Azure Key Vault for storing your certificate, and then you can use them in the workflow. EV code signing certificate, I'm not sure what this means. I'm not very familiar with this type of maybe you are more familiar, Alex, than me.
Yeah, I also think Catalin pasted an URL from our website. So if you want, you can check that, Scott. If that is still not clear, just reach to us and maybe we can talk and see if we can help you in any way. Okay. Okay, and the last question that I see here, this is for in-house applications. Do you have for vendor-msi, MST, asylum, setup.exe? Well, again, this is more tied with what Arun asked, and from my point of view, GitHub is not a feasible scenario for this. So if you want to automate the repackaging of an application, you don't do it in GitHub. We offer support with multiple tools like VMware Workstation, and we do have automation implemented in Advanced Installer with PowerShell, for example, and you can think of better scenarios of repackaging your applications in that way rather than do it in GitHub. I think you can do it. I'm not sure. Technically, you need to use the PowerShell to learn how to install your application first and then maybe deploy a repackager. It's not something we can test it, and I'm not sure if it works. Chip, maybe it works,
also,
but
it's
not feasible.
Technically, you can do it, but
yeah.
It does not mean that you should, because being a free service, GitHub runners are shared with other users. So on a GitHub machine, several workflows might run at the same time, and they actually do run at the same time. And repackaging, for example, on such a machine, it's very tricky because you get a lot of noise. Also, they are very slow because again, they are shared resources. But technically, yeah, it can be done.
Technically, yeah, but not recommended. And
yeah.
I think that's the best explanation for that. I don't see any other questions, Christina.
Yeah, so these are probably all the questions for today. If you have any other questions, please send them to the email address support@advancedinstaller.com, and we will come back to you with all the answers. Thank you for being with us today. So we have another one. Thank you. Yeah. Thank you for all the questions. Thank you for attending this webinar. Thank you for your feedback and for your interest. And we will see each other again at the next webinar. Thank you guys for being with us today. So
Thank
have
you,
a nice
everybody.
evening. Have a nice day.
Bye,
Yeah.
everybody.
Bye-bye.
Bye.
Bye.